Hey everyone, it's that time of the year again. Here's my submission for Festive Tech Calendar 2023. And we're going to build a ChatGPT app, basically a chatbot, that works with custom data. We're going to build it using a low-code approach, and that's going to be a combination of Azure and Power Platform components. Now, I am Geert Baeke. I work as an Azure and AI architect at Kronos, Belgium, and I'm also a Microsoft Azure MVP. Of course, I'll be happy to welcome you if you reach out using X or LinkedIn, and please follow my blog and YouTube channel for related information about these technologies. We are going to build an application that is very much like ChatGPT or Copilot Chat in the sense that you can ask questions and you'll get a response. But of course, the models we're using, like GPT 3.5 or GPT 4, they have some knowledge lacking to answer the questions that you ask. For example, if you asked this a few months ago, who is the King or Queen of England, you would have gotten the response below, which is of course not up to date. Now, what we can do with these models is we can provide them with extra context or extra information. And if you're using Copilot Chat or you're a ChatGPT Plus subscriber and you enable Bing, what happens is that this application can first browse the internet, search for relevant information, and then feed that relevant information to the model to answer the question that you asked. So in the second example, after the Bing search is finished, the answer, who is the King or Queen of England, is answered correctly. And we are going to do something very similar to chat with our own data. We just have to find a way of handing over our own data to the model, and more important, we have to make sure that that information that we hand over is relevant to the question that we ask. Now, what is the general picture here? Well, first of all, you will have some documents in some store. That store could be anything. It could be a file share, it could be SharePoint, it could be blog posts on a blog, for instance. These documents will be in a specific format, doc, PDF, HTML, Markdown. That doesn't really matter, but we have to ensure that we convert it to text because LLMs work with text. That also means, for example, that when you have PDF documents that contain written text, you have to use some form of OCR. Now, what we are not going to do with these documents is we're not going to hand them over entirely to our large language model because that would be too much information. It would also be too costly. So in the second phase, we're going to split and store these documents. The splits that we create here, we also call them chunks. We're going to save them in some form of database. Now, I said here it's a vector store. That's going to be typically the one type of database that is going to be used. But it doesn't have to be just a vector store. It can be any search index that supports any number of search mechanisms. That could even be just full text search. But vector search is typically the recommended approach. I will explain more about that in a moment. So this is going to be our first step, loading documents and then splitting and storing these documents in some database. Now we come to the user part, where the user is going to type in a query. When the user types in a query like, who is the King or Queen of England, what will happen is we have to find relevant information to this query. So we're going to ask a question to our vector store or our search index, and that one hopefully comes up with relevant docs, pieces of text, maybe 5 or 10 or whatever you want to do. Usually we see that we hand over 5 pieces of smaller text, and we hand them over to our LLM via the prompt. Indeed, the prompt is something that we build in the background where we repeat the question, who is the King or Queen of England? And then we add pieces of text as context, and we ask in the prompt to only use the context as a source of information and not to start freewheeling or hallucinating as these models can sometimes do. For the application that we are going to build, we're going to use as a source of documents blog posts on my blog, and we're going to use the RSS feed to read the last 50 posts, in my case, from my blog. Now, every blog post will be chunked into smaller pieces. The HTML will be converted to text, and we're going to store these smaller pieces of my blog post in a search index. We are going to use Azure AI Search, formerly known as Azure Cognitive Search. And in that service, we're going to create an index. An index is just a collection of documents that are JSON documents. The JSON document, in my case, has a simple list of fields. It has an ID field that's going to be a unique number, the title for my blog post, the URL for my post, and then the content, which is clear text. Again, remember, this is going to be a piece of the content of one post. It's going to be a chunk. So it could be, for example, that one blog post has 7 chunks. Well, all 7 chunks will be a separate document within the index. And for each piece of content which is text, we're going to create a content vector as well. That content vector, to remember for now, is going to capture the meaning of the text. I will explain more about that in a moment. Now, from the moment that we have our Azure AI Search Index, we can start with, well, let's say the more low-code approach, because we are still going to use some Python to build the index. We're going to use the portal to link the index to Azure OpenAI, which has an Add Your Data feature. So you can directly test if the index works well with the LLM of your choice. And when you see that that works well, you can actually then export the configuration to either a web app or a Copilot Studio chatbot, formerly known as Power Virtual Agents, right? And that name is still used in the Azure OpenAI wizard, because at the time of creating this video, that wizard wasn't updated with the new naming yet for Copilot Studio. We chose Copilot Studio chatbot as the export mechanism, because then we can use again low-code approaches to modify that chatbot. Now, what about this content vector field? What you see now on the screen is a search result where that result is giving me my ID, title, URL, and content field, but also the content vector. And if you look closely, the content vector is just a list of numbers. It's a list of floating point numbers. In this case, it's 1,536 numbers. And just remember here that the combination of these numbers reflect the meaning of the text. It will allow us later to find out if pieces of text are similar to each other. It will also allow us to calculate, for example, if you have a query like who is the king or queen of England, what pieces of text are closest to that query. And hopefully that will deliver us with some relevant results. Now, if we put that into a bit more perspective here, we can use this illustration to illustrate the concept. Instead of using vectors with 1,536 dimensions, which are a bit difficult to reason about, let's think about vectors in 2 dimensions, on an x and an y axis. Well, then we can draw, in a very simplified way, of course, the query here as the red arrow. And here we have, of course, the vector for the query. That's drawn here in red. Next to that, we have vectors for documents that are quite close to it. These green ones are closer than the orange ones. And suppose we decide to keep the green ones because we think that these will be the most relevant pieces of text to our query. Of course, we can see this visually on this chart. For our system, when we build the app, we'll need to be able to calculate the distances between the query and all the different vectors that we stored in our database in an optimized and efficient way. And that's something that Azure OpenAI Search will do automatically for you. Now we get to the question, how do you create the vector? Well, you can use what is called an embedding model provided by third parties. In this case, OpenAI has created the text embedding ADA 002 model, and Azure in Azure OpenAI also provides that model. You should see such a model as like a big function that takes text as input and a vector as output. Now, the text that you put in is going to be also limited in size. That's also one of the reasons why we chunk our documents, to be able to vectorize them efficiently. And when the model gives you the vector as output, in the case of OpenAI, it's going to be 1536 floating point numbers. If you use other embedding models, you might have another number of dimensions. For example, 384 is something you'll also see quite a lot. Now, together with that model, the creator of the model typically says what kind of distance function to calculate the distance between vectors should be used. OpenAI recommends cosine similarity, but luckily Azure AI Search will do this calculation automatically for us with this one as the standard metric. We talked a lot about vector search because it's recommended that you use that type of search when you're building applications like this. It's very good at finding pieces of text relevant to the query that you typed. But vector search is not great in all situations. For example, if you're looking for specific words, or maybe like product IDs, etc., then vector search might not be good. In that case, you can still do a keyword search or a free-form text search, and Azure AI Search supports that. Even better, you can combine free-form text search with vector search in a hybrid search. What happens in that case is that in parallel, there's a text-based search being done and a similarity search with vectors. Those results are then merged, and the best results are put at the top by using some re-ranking algorithm. We typically recommend that you try hybrid search in your scenario to see if that is yielding the best results compared to vector search or freeform text search alone. Even better, today you also have the semantic ranker or re-ranker generally available. It will look at the results compared to the query, and based on models designed by the Bing team, it will try and see what is actually most relevant here and put the most relevant results at the top. So it's a re-ranking model. And since November, it's generally available with new pay-go pricing. So for free, you get 1,000 requests per month, and then it's an additional $1 per additional 1,000 requests. Again, we highly recommend to also turn on semantic search and see if that improves your application. And if it's not needed, of course, you don't have to use it and just keep yourselves to hybrid search or vector search alone. That's, of course, dependent on the application that you build. Now, enough slides, I think. Let's take a look under the hood and let's build the Azure AI Search Index. Let's take a look at the Azure AI Search instance first. I've taken the basic tier, and if you look at the basic tier is something that allows us to scale to something like, if I'm not mistaken, 2 gigabytes of storage, but that does cost 70 euros per month. Remember, there is a free tier, which is limited to 50 megabytes of documents that you can use to play around with the service. Now, I will focus on the indexes, and the index we're going to build is this blog index. You can disregard the other ones. Now, already take a look at the fact that my document count for my blog index is 292, although I'm only taking into account the first 50 blog posts on my blog. This, of course, is a result of chunking. Now, when we look at the blog index, we can see what fields are defined on the index. Here we see indeed that ID, title, URL, content, and content vector. We can do searches directly from within the portal to see what kind of results we are going to get. And because I defined a vector profile with an integrated vectorizer, I can actually do vector searches directly from within the portal. But this requires what you see here, a vector profile with a vectorizer defined. And here you see that the vectorizer is using an embedding model, the Azure OpenAI embedding model. I call that model embedding, but actually that Azure OpenAI ADA 002 model is behind this. So because I pointed Azure AI Search to this integrated vectorizer, I can go to Search Explorer and I can actually do a vector search. Now, I do that from within JSON view. That's going to be easier. And here I can specify the vector query I want to do. For example, what is the OpenAI Assistant API? I have a blog post about that. So I hope that the most relevant result is that blog post at the top. Now, I don't want to do a hybrid search in this case. If I want to do a hybrid search, I just repeat this question here in this search field. But I'm not going to do that. I'm going to delete this. I only want to do a vector search. And I don't want to do a semantic re-ranking step afterwards. So I'm going to remove the semantic re-ranking here as well. So this is just a vector search. It's going to search in the vector field called content vector, and it's going to give me the 5 nearest neighbors, the 5 nearest chunks of my blog, nearest to this text here. Remember, this text, this query text, is going to be vectorized by that embedding model that's in my vector profile. Let's do a search and see what happens. And indeed, I see that the first result is trying the OpenAI Assistance API. So this is actually quite a good result. So we see already that it works quite well from within Azure AI Search. Now, if you want to follow a fully low-code approach to also creating an index, Azure AI Search also has a couple of wizards that allow you to do just that. For example, if you have your content already in blob storage, maybe you have all created PDFs from the blog posts, or you just have PDFs and other documents inside blob storage, you can use this import and vectorize data. For example, here, I could select a storage account from my subscription. I can select a container here, even enable deletion tracking. So it removes documents from the index if they are removed from Azure Blob Storage. And then, just like with the integrated vectorizer, I can tell the system you have to use an Azure OpenAI instance with this embedding model we talked about earlier. Of course, the embedding model has a little bit of a cost associated with it, so I have to acknowledge that that will incur additional costs to my accounts. In this kind of wizard approach, you can also easily enable OCR. In that case, you do require a multi-service Azure Cognitive Services account. I already have that, so I can just select that and again acknowledge that that will, of course, increase my cost. I also can enable the semantic re-rank, but I'm going to disable that for now. And I could even say I'm going to schedule this every half an hour, for example, to ensure I have an up-to-date index. When I click Next and then Create, what happens is that an indexer will be created. That's a background process that is going to, on a schedule, go to my blob storage, go to grab that data in there, chunk the data, vectorize the data, and populate my index automatically for me. Now, I cannot use this approach here because I have my content on my blog, and I'm going to show you how you can push content to an index using indeed a push approach. This is a pull approach where the indexer pulls the data from a storage account. I'm going to push the data using my own code to my own custom index. Let's see how that works. Let's take a quick look at the code that pushes the data from my blog to an index. I'm not going to explain the code in detail. This is merely an illustration. So here I have some code that defines the index. You can see that we define the list of fields. They match with what you have already seen in the portal. We also have a vector search profile, and this function just returns the definition of an index. So a search index with a name, with my fields, and then a vector search profile. It does not create the index. So let me just run this to define the function. Next, we are just going to get the items from my blog. So I'm using a module called feed parser to get the latest 50 feeds in my case from my blog. Then I'm going to set up some helper functions that allow me, for example, to determine the length of the chunks I'm going to create. I also have a helper function that can create an embedding for me using the OpenAI embedding model. It takes text as input and returns an embedding as output. Then to chunk my blog post into smaller pieces, I'm using some help from LangChain, which has a recursive character text splitter. I set up this text splitter to create chunks of 500 tokens in size with 100 tokens of overlap. So we repeat some of the text between the chunks as to not lose context. Here you can make a difference by, for example, trying out different chunk sizes and overlaps to see what works best in your scenario. Now, when we have defined all these functions, we can loop over our posts here and then create chunks from an article that we retrieve, right? So article contains my blog post content, and then these chunks will be one or more chunks coming from that article. Now, the chunks are what are going to be stored in Azure AI Search. So then we can create our JSON document that you see here. And what I'm doing here is a very simplistic approach. I have a search docs Python list, and for every chunk I have, I append a JSON document to it. The ID will be some hex digest based on the chunk of text. And of course, the title is the post title, the URL is the post URL, and the content is not the entire blog post, but a chunk of the blog post. The content vector contains the embedding for the chunk. So this will be this list of 1536 numbers. When I run this, it will take quite some time to do so. So I will do it, click here, and what you'll get is that we're now going to start to my blog. And first of all, I say that I found 50 posts, and post 0 has 6 chunks. That means we have a total of 6 search documents now. And we continue to do so until we reach 50 posts. I will pause a bit here and at the end show you the result. We are now at the end of the process. We have processed 50 posts from 0 to 49, and in total we have 292 documents. You have seen that number already in the index that I showed in Azure AI Search. Now it's time for us to create the index, and if it's already created, to update the document. So we have some code here that can authenticate to the search service. So we have the service endpoint here. We get this from environment variables. We have the name of our index, and of course we need a key to authenticate. Now, to create an index, we create a search index client and authenticate to it. And then we get the definition from the index using the blog index function. And with this single line of code here, we create the index in Azure AI Search. Now, when the index already exists, there will be an error. So I'm just using this try except block to quickly go over that. In the end here, you see that we build a search client. The search client is able to use an upload documents function to batch upload a number of documents at once. Now, there are limits to the size of documents you can upload using this upload documents. If you have too many documents to upload, you'll have to do some batching yourself and do it in stages. Now, let's see if this works. So I'm going to click here. And it shouldn't normally say the index probably already exists, but you will keep on adding documents to the index. Now, of course, because my blog hasn't changed, the chunks haven't changed either. That also means that the IDs are the same. And this means it will merge the chunks it has now in this code. It will merge the chunks with the chunks already existing in my index. So I will stay at 292 search documents here. Okay, now this has finished in about 4.9 seconds. Now let's see if we can do vector search from code to see if this works. So I'm gonna do a vector search, not gonna explain in detail here, but we're gonna do a vector search for Assistance API. Well, let's run this code. What do we get back? We get back a couple of articles, The first one is already trying the OpenAI Assistance API. But I can also do a hybrid search. In this case, I'm doing both search text and vector queries. If I run this, I'm doing a hybrid search. This one is for how to use managed identities with AKS, and I'm getting 5 relevant blog posts here. You have now seen 2 ways to create an index. The push mechanism from your own code, and then a pull mechanism, which was illustrated by using that wizard. It's recommended, if you can, to always use the pull mechanism with an indexer, because then you have a background process that keeps your index up to date. It also allows you to add skills, for example, AI skills that do OCR. And that can be done automatically for you instead of you having to programmatically build that in. Now, before we continue putting our index to work together with Azure OpenAI, I want to do one last thing. I want to enable a semantic configuration on my blog index. I already did that, but it's just a matter of adding here a semantic configuration and then specifying the fields. I specify the title field and the content field. You can see that here, if you click on that, you have the title and then your different content fields. And this is used by the semantic re-ranker I talked about earlier to intelligently promote the most relevant results in a search result. So after you have done, for example, a keyword search or a vector search or a hybrid search, this semantic re-ranking can be run as cherry on the cake to get the best results for your application. What I also have to do if I want to use this semantic re-ranking option, I have to also turn on the semantic ranker. I turned on the free plan, which is giving me 1,000 requests per month. In production, of course, I would select the standard plan as to not get stuck on that 1,000 requests per month. Great. We have now done all we need to do from the Azure AI search point of view. Let's look at how we combine this index with Azure OpenAI. To add our index to an OpenAI model, we need to use Azure OpenAI Service, which is Microsoft's implementation of the popular OpenAI models. Now, Microsoft also added their own features on top of this, and one of that is bring your own data, which is in preview today. And it does exactly what it says. You add your own data to it, so a model like GPT-4 can answer questions about the data that you have connected to it. Now, what do you need? Of course, an Azure subscription, speaks for itself, but also access granted to use Azure OpenAI. There's still a form you have to fill out, but once that's done, you can deploy Azure OpenAI in a region of your choice. In Europe, for myself at least, that would typically be something like France Central or maybe even Sweden Central, where all or most of the models are available. What we also need is a chat model. That can be GPT-3.5 Turbo or 16K version of that. That will be faster to respond. If you need, let's say, a bit more reasoning about your data, then GPT-4 or GPT-4 Turbo, which is in preview today, might be the one that you want. In Azure OpenAI, you have to deploy the models as well. So here you see in the screenshot that I have a deployment of the Azure OpenAI resource, and then I deployed several models within that resource. As a next step, you will just link your index to the chat playground. The chat playground is a place where you can indeed play around with prompts and see how the model responds. We can add our data here and start checking if the data is okay and if we can ask questions about that data. When we are pleased with the result here, we can then export this to Power Virtual Agents bot, but also a web app. We will deploy this to a Power Virtual Agent bot, which of course is now called Copilot Studio. Let's see how we do this and implement the Baeke.info bot. To connect our index to Azure OpenAI, we first have to have an Azure OpenAI resource. I have one here deployed in France. Now, I don't need to be here in this interface. I'll need to go to the Azure OpenAI Studio because there I can access the playground. Now, I could go to the playground directly here, chat, and then add your data, or just click here, bring your own data. This lands you in the chat playground and directly into the Add Data wizard. Now with this wizard, you can select the existing index that we created about my blog, or you can actually say, I'm going to point to other data, for example, data in blob storage, data in Cosmos DB, or even upload your files now using an upload feature. I'm going to select Azure AI Search here and then select my search instance and my index. Now, my index is called blog. I could add vector search to this index, and as I said, that's often the best way to go, having vector search, maybe combined also with keyword search and semantic. And if I do so, I can go to the next phases and use that. Now, we are going to export this experience later to a Power Virtual Agents bot. Currently, the export feature or Power Virtual Agents is not able to work with this vector search feature. So I have to disable it for the next parts of our demo to work out. If you're going to deploy this experience to a web app, as I'll also show later, then you can add vector search. But for now, I won't do it and just click next. Now, this wizard expects certain fields to be there. For example, a content field, a file name field, and so on. You can map the fields in your index to the fields it expects. I don't have a file name, I do have a title, and I do have a URL. When you have vector search enabled, you will also be asked to provide the vector field. But in this case, we don't do that. I'm going to click next. And so I will select now not just keyword, but I'll do keyword and semantic in this case, and acknowledge that semantic search can add extra cost here. So I'm going to go save and close. And now we have our data added here in the Add Your Data preview section. Here I can see the data source. In the advanced settings, I can limit the responses to my data content. So the model only answers about the content it has or it knows about. You can play around a bit with the strictness level and the amount of documents that are retrieved to support the answer that the model is going to give. Normally, the default is fine to start with. I'm also going to select the model that will answer the actual questions. I'm going to select GPT-4 here and take into account this is 1106 preview. That means this is actually GPT-4 Turbo. So I'm going to select this and then ask a question about content on my blog. For example, what is the OpenAI Assistance API? API. I can also leave it in with an error here. That's okay. And then ask this question and see what happens. And it of course will tell me in this case what it is all about. So it answers. It did a keyword search and then also a semantic re-ranking on top of that. And I have 3 references, they call them citations, and this is the actual content or context that has been given to the model to formulate the answer you see here. If I ask here now a follow-up question, for example, how to create a thread, which is related to this assistance API, then hopefully it knows that it's about the OpenAI Assistance API. And yes, here we get the answer, how do we create threads? So this is great. We now see that search is working with our data, the data coming from my blog. Now we can think about bringing this to our users. And there are 2 ways of doing it. I either export this to a new web app, or I export this to a new Power Virtual Agent bot. If I click this second option over here, you'll get this screen. Be aware that if you did turn on vector search in the setup, the Add Your Data setup, you will get a message here that says that vector search is not supported. Okay, let's click Continue in Power Virtual Agents. When you click Continue in Power Virtual Agents, you actually get into Copilot Studio, because that's how Power Virtual Agents was renamed recently and the wizard hasn't been updated yet. You then get this screen. If you properly authenticate with an account that can create these kind of copilots, you then get a screen where you can give the copilot a name and a language. And we don't have to worry about this boost your conversations with generative answers here, because that is actually to link a website to Copilot Studio. We will link a custom Azure AI Add Your Data index to it. I can go to edit advanced options here, click some icons, stuff like that. I'm not going to include the lesson topics, and then just click create to create the bot for us. Now you land in the Copilot design interface, where you get some, let's say, new features about Copilot Studio here. So yeah, next, yeah, I understand, fine. And now we can basically start building our bot here. Currently, might be a little bit confusing if you start asking questions here. For example, what is the OpenAI assistant? Let's see if it works. Just like in the chat playground, you might get things like, I'm not really sure, or can you try rephrasing, and so on. What normally has to happen is that in the topics, there should normally be a conversational boosting topic that is using AI and is using an Azure AI search index to answer questions. Now, that wasn't created automatically. So what you'll have to do here is you'll have to add a generative AI option and actually say, I want to use generative answers here without specifying websites or anything else. Just do this and click save. What you'll get then is you'll get in the topic screen, you'll get a additional topic, and this one is called conversational boosting. And it will work when the intent is unknown. So when Power Virtual Agents, Copilot Studio doesn't really understand what you try to do on its own, it will then fall back to this topic and then use the create generative answers action over there. Now I'm going to switch to a Copilot already created to show you a little bit how that create generative answers section here is built. So here we are in a working Copilot where I asked the question, what is the OpenAI Assistance API? And we can see that the bot is responding similarly to what the response was in the OpenAI Studio, with including the citations as well. So I can see what the context is that was provided to the bot. And I can even then click on the link here to go to the actual website. Now, what has happened is I configured the create generative answers section over here, the data sources section to be more precise. Because what happens when you go from the chat playground to the Copilot Studio is that normally it should create a connection back to the Azure AI Add Your Data feature and also set up this generative answer section properly. The only thing it did though is it created the connection for you, but it didn't configure the entire data source. So what I did was I went to edit here in data sources, and then you'll find at the bottom, you'll see there that we have a connection to Azure OpenAI. So that connection is there, but the connection properties, when you first create your bot, they might be empty. So in this case, I configured GPT-3.5 Turbo as the deployment. I set the API version and so on. These are things you all have to add yourself. And I can also go to the model data, and there I can specify indeed what is the index name. Well, let's blog. The title is mapped to title. We have the URL. We have the actual content data. We turn on semantic search as well. Query type is semantic, so here for some reason vector is not supported, and that's it, right? So here we have the configuration of the Azure AI Add Your Data feature. So again, whenever you ask a question that does not match a topic that I'm going to leave this here, that does not match a topic like, for example, a greeting like hi, that they can answer himself, he will actually go here and use the conversational boosting topic. So indeed, yes, when I'm doing something like hi, when I'm doing that, well, then I'm not going to my Azure OpenAI add your data feature. The bot will answer on its own. But when I ask a question it can't answer, then of course it'll try to do the generative answer. Okay, that's great. So we have our Copilot Studio chatbot created. We have this conversational boosting topic added, and we configured the data part of that to point to our Azure OpenAI search index. Now, what if I want to do a little bit more in this bot? Well, in that case, of course, I can do or use the regular bot features. For example, I have here something which is called new posts. Here I'm saying, well, I want to know what's new on the blog. The problem is that with this add your data features, if I'm asking what is new on the blog, well, the GPT model cannot answer that question because it doesn't really know what is new on the blog. There is no content in the index that says, hey, this blog post is new. It is not there. So what I want to do here is I want to connect certain questions, certain trigger phrases to actions. For example, this is an action. So an action built with Power Platform that's using the RSS feed information, and that gives me the last post here. For example, so if I'm saying here what's new, or what's new on the blog, and we ask for this, we should normally see that we're getting in this action here, and he says, hey, you should go to blog.baeke.info, but the last post is actually finding images with text and image queries with the help of GPT-4 Vision. That's of course what this custom action did. So what you'll often do is you'll combine your bot, of course, with this conversational boosting topic. You will be able to answer questions based on content and use an OpenAI model to formulate the answer. But for more, let's say, structured activities, there you might not want to use something like GPT and just use standard actions and activities within that bot. Another example of this, for instance, is if you go back to topics, you will also see that there is a topic that says, hey, I'm asking for a new post. So in this case, I want to request a new blog post. Then I want to ask some information from the user, have some blog post details. I submit that. And when I have submitted it, what I'm going to do is I'm going to add this to an Excel sheet. So I can see, for example, hey, somebody asked for a new blog post. I'm going to try and create that blog post here. Again, this has nothing to do with GPT and with add your data. It's just the combination of using the add your data feature and then embellishing, enriching the bot with additional functionality that's in Copilot Studio. So if I'm asking here, for example, I want to request a new post. So I want to request a new post. We should normally end up here in this adaptive card, and I'm asking for a new blog post. What's new in AKS, for instance. And I can say here, well, it's been a long time since you've written anything about that, etc. So I submit this, and what will happen is after I submit it, we will add this to an Excel sheet, and then I can see in that Excel sheet that somebody asked for this new blog post. If you do not want to use Power Virtual Agents, but you just want to have a web app for your users, you can actually use a new web app instead to deploy to. You'll get this wizard, which is kind of straightforward. You give your web app a name, subscription, your resource group, and location, then select the type of web app pricing plan that you want. And if you want to have chat history similarly to ChatGPT, where you can all see your previous chat history in the UI, you can enable that. Now, be aware that also deploys Cosmos DB to keep the chat history. Now, I already have a web app deployed like this, so I want to quickly show you what that looks like. So here we are in the deployed web app, and let's use the same question again. What's the OpenAI Assistant API? And we should normally get the same response back here. right? So we click on this, and there we have the question, and there we get the answer here. Again, with references built in, with the citations you can click on, and then here you indeed see the actual citation. What is nice as well, because I did enable chat history, that you can see your previous chats with this application. And because you are integrating, or this app is integrated with Azure AD or Entra ID or whatever it's called these days, we of course know who the user is, and we keep the history per user in a Cosmos DB database. So if you just want to deploy your application, your bot, using a web app, this is going to be the simplest approach. Now, be aware that this web app is actually based on some code here. This is my web app, and there you'll find the external repository project. So Microsoft created this, let's say, sample application. So if you are aware, or if you know how to modify applications, if you have pro developer skills, you can modify this application. The backend is written in Python, and you can easily make some changes there. And with that, we have come to the end of this presentation. To wrap up, you have seen how to build an Azure AI search index and populate it with the data that you want. We use the content on my blog, but it could really be anything. We then added that index to Azure OpenAI Add Your Data to start asking questions about the content that's in the index. And we use GPT, a GPT model, to formulate the answers to our questions. And then we have seen how we can bring that model, that application, to our end users right from within Azure OpenAI Studio to a web app or to Copilot Studio. And the nice thing is, although we didn't show that, is if you have your Copilot in Copilot Studio, you can easily embed that application in, for example, Teams or any other web app of your liking. Great. I hope you liked this submission for Festive Tech Calendar 2023, and hope to see you again some other time. Bye bye.